So today I'm going to show you how to make a cool heat map like this. I made 3 heat maps. They can be useful for a number of things, especially if you want to visualize um, technical numerical values of some sort. Here I've got 3 different ones. One which states the accuracy measures of various machine learning models. The other here states the log loss and the AUC. Doesn't really matter. The only thing that we're going to focus on today is creating this visually appealing visualization. And yeah, so let's just get right into it. Here I have some data. Like I said, you can basically use any type of data that you want or you like. But as you can see, here we have measured various cross-validation fold configurations in machine learning. And we have the accuracy scores, the AUC scores, and log loss scores. There's a lot of numbers for Model 1, Model 2, and Model 3. But I mean, you can use any type of data that you want, as they are important to my visualization. And I guess I will put it here. We have the fold configurations, and then we need to specify the various categories. In my case, it's the various machine learning models. So we have XGBoost on top in the first column, and then we have light gradient boosting machine in the second column, and then we have random forest in the last column. Just gonna, yeah, let's make that same size. We have the full configurations. So there's like a cross here. And then we're going to make 3 of them, one for accuracy, one for AUC, and one for log loss. So we're going to start with accuracy. I'm just going to copy over my numbers here. Yep, make sure that they are aligned with the fold configurations. I moved it 1 step down because I'm going to create a header, but you know. So we have the accuracy scores now corresponding to each fold for the XGBoost, and we need accuracy for the second machine learning model. I'm going to put it here, just copying that over, and the same goes for the last one. So that's the numerical data from this column. There we go. That's actually a big part of it. Now we have the accuracy scores for all 3 models in correspondence with each fold configuration. And we're also gonna copy this score type. It needs to correspond with the values. But you know, your data set is gonna be different from mine, so just make the proper arrangements. This is the information. So there we go. So what we want to do now is color map each of these. We can see we have a lot of numbers. They're all 0 point something. They range between 80 something, 87 perhaps, 0.87 and 0.93, which is going to be useful. We need to just have a quick look at the data. But for now, okay, we have this. And then we're going to hover over to this section here, conditional formatting. This is where we create the colors. You can explore it, you know, there's different things you can do here. You can add the data bars, which kind of showcases, yeah, it's a way of visualizing the each cell. But we're not going to do that today. We're going to make the heat map. So then we go to color scales under, again, conditional formatting, color scales, and then we head over to more rules. Then we get this new formatting rule window here. You can choose between a couple of different types of scales. I'm going to go with the 3 color scale, just because I like that. So here we can specify the color of the minimum, the midpoint, and the maximum value. So the minimum color, we're not going to change that, but we're going to change the color. I think purple is pretty cool, so I'm going to get that one. And then in the midpoint can be green. The maximum, yellow. And then we just click OK. And we are already starting to see the contours of a heat map. Just going to move the numbers a bit, a little bit better. Yeah, centralize them here. So what this tells us is that the lowest scores in this table is indicated by the darker colors, and the higher scores is indicated by the more yellowish and lighter colors. So just by looking at this, I can see that these two scores are significant. The same are these, and also all of this. Actually, it tells me a lot about this model and its threefold configuration, but that's a different thing. You have to spend some time, just try to understand what the values are actually telling you. Since this whole rubric is dedicated to the threefold configuration and this to the 5, I'm just gonna take these here and merge and center them and put them in the middle, so they kind of like goes with this whole section, and I'm going to do that for all of them. So I just merge and hang on. I just merge and center and then put it in the middle. You don't have to do this, but it kind of looks nice. Looks comprehensive. That's like the goal, with the goal with visualization is to make technical data more easy to interpret. So, and if we were to present this, we're actually almost already there. But if we were to present this, it would be nice to also put in a scale, a scale, so it's easier to just read the data. So like I said earlier, we were talking about the highest and lowest scores, and they're gonna be the indicators. So we have 0.87 something, 0.88 actually. No, let's start with the highest score. And we have 0.3, 0.2. So we can say that the highest score is 0.4, just 0.94, just to be specific. My formatting does this automatically. Maybe yours does as well, or I'm going to show you different ways. So we have the high score there. And then we can, since the range is not that big, it's from 0.94 to 0.87. I'm going to choose a single step. This is a single step, 0.94, 0.93, 0.92. And then actually we can just copy all of these and then drag them to our lowest score, which was 0.87. And there we go. That's our legend, our scale indicator, if you'd like. And there we have it. And if these weren't, if these didn't update automatically, we could just follow the same procedure, selecting the data and then setting up a new color scale through more rules, just like we did, But they updated automatically, perhaps, maybe because they're connected. In the right field here, we can specify the range of the scale. We have high, medium, and low. I'm just going to change these to the same font consistency. Actually, since we have 1, 2, 3, 4, 5, 6, 7, 8, we have 8 cells. This medium thing is kind of in between. So we can do the same here and merge this and center it. So it's in the exact middle. And there we go. This is a heat map. One more thing. To enhance the visual representation, we can go ahead with the darker colors. You can see it's quite hard to read the black numbers. So we can go ahead and take, say, half of the scale from the medium point and make those numbers white, so they're easier to see, and it's also going to be easier to differentiate in the table. So our crossing point there is at 0.90 or 0.91. Then we can essentially, anything in the table less than 0.90, I'm going to color white. So all of these are below. I was just doing this manually. There might be a more efficient way to do this, but I'm just doing it manually. And this further enhances the readability of the table. I think that was all of them. Yeah. If you'd like, you can also put in a header. We were concerned with the accuracy data in this. So I'm just going to write that accuracy heat map. And for consistency, we change it to the same font, maybe like this. So this is our heat map. Indicate, yeah, that's how it's done. Maybe this could be valuable to somebody. Maybe you want to try to visualize your data in the same way. It's a creative and fun way to do it. So good luck.